Good afternoon. My name is Zsófia Vincze, and I would like to present you my PhD topic, which is the evaluation and comparison of different complete denture processing technologies. I'm a dentist from the Department of General Dental Preclinical Practice. My supervisor is Kristina Márton. My scientific methodology supervisor is Kata Kelemem. My vision is to resocialize edentulous patients into the community by providing them a durable and well-functioning complete denture. I have two ongoing projects. The first one is investigating the mechanical properties of denture-based resins, which will be a systematic review and network meta-analysis. Edentulism is very common, especially among older people, which can lead to functional limitations and can cause social isolation. According to the United Nations, by the end of 2050, there will be twice or even 3 times more aged persons than nowadays. That is why we have to be prepared and be able to provide a solution for them. The most common treatment option is the complete dentures, which can be made by the dental technician, but it can take longer time. Or we can use the newer CAD/CAM technology, the additive 3D printing or subtractive milling, and with that we can reduce the cost and number of processing steps needed. When patients are using the complete dentures, it repeatedly undergoes flexing during mastication, and it can cause a fracture or a crack. And if the surface of the denture is rough, more bacteria and candida can connect to the surface and can lead to oral infections. That is why our aim is to investigate the mechanical properties of different types of denture-based manufacturing techniques. Our clinical question: is there a difference in mechanical properties of CAD/CAM produced complete dentures and conventional complete dentures? And our hypothesis is that there is no difference between the conventional, milled and 3D printed denture bases in terms of flexural strength, surface roughness and elastic modulus. We would like to find alternative methods to produce complete dentures quicker and cheaper without the decrease of quality. I conducted the systematic search at the end of November last year in 4 main databases, and I ended up with a little bit more than 17,000 articles. By the end of the selection process, we could include 66 eligible full texts. I would like to show you some of my results. The first one is the flexural strength, which is the ability of the material to resist bending deflection when force is applied to the surface. High flexural strength is very, very important when we are talking about complete dentures because, as I mentioned, it repeatedly undergoes flexing during mastication, and an average bite force of a human is around 100 Newton, but the maximal bite force can be around 300 Newton. Just to put it simple, if the flexural strength is low, our denture will break sooner. That is why there is also an ISO standard which says that an acrylic denture base has to have at least 65 megapascal flexural strength. We can measure it by using the 3-point bending test when the specimen is laying on 2 supporting pins and the force comes from the top, and first it will bend the specimen and after a certain point it will break. Now I would like to show you some of my plots. The first is the network plot, where the orange circles show the 4 fabrication methods. The size of the circles shows the number of specimens which were made with the given technique. The lines shows the direct comparisons, and the number on the line shows the number of articles where these comparisons were made. Altogether, we could include 37 in vitro studies for this outcome. On the right, you can see the p-scores, where the values range from 0 to 1. The higher the p-score, the higher the likelihood that the given technique is in the top rank. If it's closer to 0, it's more likely that that technique will be in the bottom rank. In this case, the milled group showed the highest p-score. And on the bottom you can see our heat plot, which contains point estimates of relative effectiveness for all possible pairs of fabrication methods, along with 95% of confidence intervals obtained with random effect model. Here the effect was the mean difference in megapascal. On the second row you can see that between the milled and the compression molded group the difference was 14.76 in megapascal, and the milled group showed the highest flexural strength, and this was also a statistically significant difference. Another result which I would like to show you is the Vickers microhardness, which is defined as the resistance to indentation. A denture can be damaged by many ways. For example, by mechanical brushing, we can create scratches on the surface, which results higher plaque retention and pigmentation, and with that, the denture's life will be reduced. So again, basically it means that if we have lower hardness, our denture life will be shorter. We can measure it by using the Vickers hardness test when a pyramidal-shaped indenture is pressed to the surface of the denture with a certain load. After that, we can measure the size of the impression, and using these numbers, we can calculate the Vickers hardness number. Again, I would like to show you my plots. For this analysis, we could include 16 in vitro studies. In this case, the highest p-score was for the injection molded groups, and the milled group was only the second. And also on the heat plot, we can see the same thing. The injection molded groups showed the best results, and the second was the milled group. But all of these differences were statistically significant. And I would like to mention strengths and limitations for our study. We could include a high number of high-quality studies which uses standardized measuring technique. Please don't look at the last one. I will delete it. Of course, we have some limitations that, for example, not all the studies investigated all of our outcomes, and in some cases, they used different measuring techniques, and the heterogeneity was quite high. In conclusion, we can say that the milled denture bases show superior mechanical properties compared to other methods. Therefore, they should be used in the everyday practice. But 3D printing needs further research to enhance the mechanical properties of the materials. Here you can see my progress. Right now I'm in the manuscript writing phase. I'm almost finished. I just have to write the abstract. After that, we will send the manuscript for internal review and submit it, hopefully, at the beginning of September. Now I would like to shortly talk about my second project, which is the evaluation of microbial adhesion of traditional PMMA resin and CAD/CAM-based dentures, which will be also a systematic review and network meta-analysis. As I mentioned, in connection with my first project, edentulism is very common, and it leads to functional limitation and can cause social isolation. The most common treatment option is the complete dentures, which we can produce either with the conventional technique or with the newer CAD/CAM technology. Even in a healthy person's mouth, there are bacteria and candida living, but in case of a denture, these bacteria and candida can connect to the surface and can cause denture stomatitis in the patient's mouth, which is very common among denture wearers. This can reduce the patient's quality of life because they can feel pain when they are eating, swallowing, or speaking. And it is especially dangerous in case of immunodeficiency or immunosuppression because these bacteria can spread to other organs, for example, to the lung, and can cause an inflammation there. So that is why our aim is to investigate the microbial adhesion of CAD/CAM-produced complete dentures and conventional PMMA dentures. Our clinical question is there a difference in prevalence of microbial adhesion of CAD/CAM-produced complete dentures and conventional PMMA dentures? And our hypothesis is that there is no difference between the conventional and CAD/CAM-produced denture bases in terms of microbial adhesion. I conducted the systematic search this March in 4 main databases, and I found almost 5,000 articles. By the end of the selection process, I could include 19 eligible full texts. Right now, I'm in the data extraction phase, but after I submit my first project, I would like to run the systematic search one more time because this is a very well-researched topic nowadays, and I'm hoping to find newer articles which I can add to my analysis. So just to sum it up, I have right now these 2 ongoing projects. The first one about the mechanical properties I would like to submit this September, and my second topic, which is about the microbial adhesion, I would like to submit hopefully this December. I would like to finish my presentation with the words of Edward Teller: "The science of today is the technology of tomorrow." Thank you.
Congratulations for the presentation, and I have a question regarding your first topic. can you investigate other mechanical properties? You mentioned the microhardness and the flexural strength in the first topic. Are there any other mechanical properties?
Yes, we could include more properties. I just mentioned these two, but besides these, we also investigated flexural modulus, surface roughness, and we could also investigate the impact strength as well. These are the most researched properties.
Thank you.
Thank you very much for your nice presentation. I have a small question for your first project. How long does it take to print a dental base?
Thank you for your question. Well, of course, it depends on the 3D printing machine and the building angle. If the object what we would like to build is placed horizontally, it takes shorter time, but I would say it's around 2 hours. But if we change this building angle either to 45 degree or even 90 degree, of course it will take a longer time. I think it can be around 3 or 4 hours as well.
Congratulations for the progress and the nice topics. Like maybe the main advantage of the compression molding and injection molding technique is the force that produced maybe intimate fitness and so retention. So like how can we recommend like 3D printing if it is maybe better mechanical properties or bacterial adhesion, but it is loose and maybe like less patient acceptability? So was there a mention of retention?
Thank you for your question. In most of the articles which I included, they did not really mention this aspect because they were focusing only on the materials, mechanical properties, which I also included. Maybe like separately we could and we should include this as well.
Thank you.
Thank you for your presentation. I don't know why I didn't ask this question before, but so it's basically a trivial question. I just don't know. So they just print the base trays.
Yes.
And how do they fix the two teeth after they made the printing?
Well, they print it different, so like using a different material, and basically they just use bonding agents. Of course, there are different brands and different types of bonding. So when a patients are using a 3D printed denture, of course, it also affects like everything. In our project, we were just focusing on the denture basis itself.
Okay, thanks.
I just have only one question. Congrats for your progress. I've seen that you're investigating microhardness, and according to my best knowledge, you've only mentioned Vickers microhardness. Did you happen to find articles with Knoop microhardness? And if you do so, or you did so, is there sufficient data for analysis?
Thank you for your question. Yes, we were discussing this topic a lot with my supervisors because we found some articles which reported the hardness using the Knoop microhardness, but we could not create a separate group for them for meta-analysis. So that's why we didn't include them to just create a big hardness group because we didn't want to grow the heterogeneity because it is already high enough. So that's why we just did not include them.